For the following matrix equation, solve for K, P, and Q. So here we have this matrix equation, and our goal is to solve for K, P, and Q. Okay, let's do it. The first thing that we're going to do is we notice that this is negative K. And so what we're going to do is we're going to take this negative K and we're going to put it in a bracket and we're going to put a plus. All right. Now, notice that a positive multiplied by a negative is still a negative. So even though we express it like this, these two are still saying the same thing. All right. So all we did was we put the negative K in bracket and we put the plus sign. But these two equations equal the same thing because positive times a negative is still a negative. All right. Okay, now let's take a negative K and multiply it by each term or each entry in this square matrix. And so we say negative K multiplied by 1 is negative K. Negative K multiplied by 0 is a 0. Negative K multiplied by 2 is a negative 2K. Negative K multiplied by 3 is a negative 3K. And so we have this matrix. We bring down this matrix 5, P, 0, and 4. And we bring down this matrix. We don't change anything, 10, 3, Q, and negative 11. Next, we need to add the entries that are on the left. I'm sorry, we need to add the matrices that are on the left-hand side. So we have to add this matrix with this matrix. Now, when you're adding matrices, you have to ensure that you add corresponding entries. Corresponding entries. So this is going to be 5 plus negative K and 5 plus negative K. We know positive multiplied by a negative is negative, so it's still going to be 5 minus K. Next, we say P plus 0. P plus 0. So P plus 0 is simply P plus 0 right there. Then we have a 0 plus negative 2K. Now, a positive and a negative is still negative, so we have 0 minus 2K. Then we have 4 plus negative 3K. Now 4 plus negative 3K, we know that a positive and a negative is still a negative. So we essentially have is 4 minus 3K. So we have is 5 minus K, P plus 0, 0 minus 2K, P plus 0, 4 minus 3K is equal to 10, 3Q, and negative 11. Next, what we do is we simplify as much as we can. So 0 minus 2K is going to be negative 2K. P plus 0 is simply P, and these two stays the same. Now, if two matrices are equal, that means that corresponding entries are equal. So that means that 5K must be equal to 10, P must be equal to 3, negative 2K must be equal to Q, and 4 minus 3K must be equal to negative 11. And so because if two matrices are equal, then corresponding entries are equal. And so we have 5 minus K is equal to 10. 5 minus K is equal to 10. That's what we got. We have P is equal to 3. Just like how we have P is equal to 3. We have negative 2K is equal to K. Negative 2K is equal to Q rather. Negative 2K is equal to Q, which we have negative 2K is equal to Q. We have P is equal to 3, which we have here P is equal to 3. And then we have 4 minus 3K is equal to negative 11. That's 4 minus 3K is equal to negative 11. Now let's solve for, based on what we have so far, we have that P is equal to Q. I'm sorry, P is equal to 3. But what is K, right? So let's solve it. So we send the 5 over. So we have negative K is equal to 10 minus 5. Again, we send the 5 over. It was a positive 5, but when we send it over, it becomes a negative 5. And so what we have is negative K is equal to 10 minus 5. And negative K is equal to 10 minus 5. We know 10 minus 5 is 5. So negative K is equal to 5. We divide both sides of this equation by negative 1. Cancel that, cancel that. So we have that K is equal to 5 divided by negative 1. And 5 divided by negative 1 is negative 5. So K is equal to 5. Okay, so let's check again. We have this another equation for K. Now these should give us the same values for K. And so what we do is we take 4 and we send it over the equal sign. Okay, so let me show that. We take positive 4, right? We take positive 4 and we send it over the equal sign. it was positive 4, but when we send it over the equal sign, it becomes a negative 4. So what we have here is 4 sent over the equal sign. It was a positive. But when we send it over, it becomes a negative. So we have a negative 11 minus 4. So we have a negative 3k is equal to negative 11 minus 4. Negative 11 minus 4 is equal to negative 15. And so we have here as negative 3k is equal to negative 15. Then we divide both sides of this equation by negative 3. When we do that, we get that k is equal to negative 15 divided by negative 3. And negative 15 divided by negative 3 is equal to 5. And so what we have is k is equal to 5 and k is equal to negative 5. Now that is not right because the values for k is supposed to be equal. So k is supposed to be one number, all right, not two different numbers, all right? But we got two different values for k. So what does that mean? Since the values for k are not equal, then the matrix equation has no solution. And so this matrix equation has no solution, and that's the answer for this question. Now, what if we had a similar question to this matrix equation? What if the only thing that we changed was this number? Instead of putting negative 11, we put 19, okay? Would we have a different result? And so let's do this similar question, but only thing, this is 19 instead of being negative 11. And so what we do here is we have our matrix equation. We have a negative k, which we put here, and we put the positive because positive times a negative is still negative. Next, we multiply each term in this matrix by negative k. So it's going to be negative k times 1 is negative k times 0 is 0, negative k times 2 is negative 2k, and negative k times 3 is negative 3k. And so we have these two matrices, which we have to add on the left-hand side. And we still have this matrix, which contains the entries 10, 3, q, and 19. Next, we add the two matrices on the left-hand side. We have 5 plus negative k. Positive and a negative multiplied by each other will give us a negative. Then we have p plus 0, which is p plus 0 is simply p. Then we have 0 minus k because 0, because positive times a negative is still negative. So 0 minus k. Then we have 4 plus negative 3k. If we do a positive multiplied by a negative, it's still a negative. So we still have 4 minus 3k. And so we have these two matrices that are equal to each other. But let's simplify this matrix on the left-hand side. What do we have? Well, we have 5k is equal to p because p plus 0 is p, and 0 minus 2k is simply negative 2k. And so we have these two these two matrices are equal to each other. Now, two matrices are equal to each other if corresponding entries are equal, all right? Corresponding entries must be equal. And so what do we have? Well, we have 5 minus k is equal to 10, and that's what we have here. 5 minus k is equal to 10. We have negative 2k is equal to q. Negative 2k is equal to q. And then we have p is equal to 3. Again, p is equal to 3. And then we have negative 3k, and here we have 4 minus 3k. Again, we have 4 minus 3k is equal to 19. And so our goal is to solve for k, p, and q. Now, let's determine what is k. So we send the 5 over the equal sign. It was a positive 5, becomes a negative 5. So we have a negative k is equal to 10 minus 5, and 10 minus 5 is definitely 5. We divide both sides of the equation by negative 1. This cancel with this, so we get that k is equal to 5 divided by negative 1. And 5 divided by negative 1 is negative 5. So k is equal to negative 5. Next, we have 4 minus 3k is equal to 19. We take the 4, we send it over the equal sign. Let me show that. So we take the 4 and we send it over the equal sign. And so what we have, right? We have 4 sent over, so it's going to be negative 3k is equal to 19 minus 4. Again, negative 3k is equal to 19 minus 4, and 19 minus 4 is definitely 15. We divide both sides of this equation by negative 3. And so should have negative 3 there. Okay, good. We divide both sides of this equation by negative 3. So this negative 3 and this negative 3 cancels out each other. So we have that k is equal to 15 divided by negative 3, and 15 divided by negative 3 is negative 5. And so we have k is equal to negative 5 and k is equal to negative 5. And so since we know what the value of k is, then we can figure what is the value of q, because q is equal to negative 2k. And so what is k, right? K is a negative 5. So if we have a negative 2k is equal to q, we insert negative 5. So we have negative 2 multiplied by negative 5, which gives us positive 10. So we have that 10 is equal to q, and q is equal to 10. And so that is how we would solve for k, p, and q, right? And so that's the answer for this question.